Okay, now we're going to add, subtract, and multiply radicals. I have a few little facts here before we get started doing some examples. It says to add or subtract radicals must have the same root and number under the radical. I gave you things that you can add. You can add the square root of 3 and 4 square root of 3. 1 square root of 3 plus 4 square root of 3 is 5 square root of 3. I'm going to show you. So remember, if there's nothing in front of the radical, 1's understood to be there. So 1 square root of 3 plus 4 square root of 3 is 5 square root of 3. 5 square roots of 2 minus 10 square roots of 2 would be negative 5 square roots of 2. So to me, I think of it like radicals. 1x plus 4x is 5x. 5x minus 10x is negative 5x. Now look, this one is a different type of radical. You have a cube root, but they are the same. Cube root of 3 here, cube root of 3 here. You have 14 cube roots of 3 plus 10 cube roots of 3. That would be 24 cube roots of 3. Okay, now look at the examples that I have that you cannot add. You may not add these two together. This is a square root and this is a cube root. You cannot add these two together. This is the fourth root. This is the cube root. This is the answer. If you had 2 square roots of 3 plus the cube root of 3, that's it. That's all you can do. And this is the answer. And this is the answer. You cannot add unless the root and the number under the radical is the same. Okay, and then the next fact I have here, sometimes you have to simplify like you do in the video that I have that's titled Simplifying Radicals. Sometimes you have to simplify before you add or subtract. Okay, so I have 6 examples to do. And first we're going to add, then we're going to subtract and add, then we're going to add, and then we're going to multiply and multiply and multiply. Okay, so can I add these two together? No, they're both square roots, but one has 3 under the radical and one has 75 under the radical, so I can't add those together. But can I simplify one of these? 3 won't simplify, but is there a perfect square within 75? Well, hopefully you say yes, 25. So 6 times the square root of 25 times the square root of 3. 25 times 3 is 75. Okay, keep this 4 square root of 3, because I can't do anything with it yet. 6 times 5 times the square root of 3, because the square root of 25 is 5. Keep this 4 square root of 3. Multiply the things that aren't under the radical, so I have 30 square roots of 3. So I have 4 square roots of 3 plus 30 square roots of 3 would be 34 square roots of 3. Okay. Looking at my next example. None of them have the same number under the radical. But if you look at them and think about it, you do have perfect squares within some of those radicals. Now the last one, square root of 2, there's not a perfect square. But look at 32. Look at 32 and look at 50. I do have perfect squares. 32, 16 will go into 32. 50, 25 will go into 32. Okay, so I'm going to do 3 times the square root of 16 times the square root of 2. And then I'm going to do minus 4 times the square root of 25 times the square root of 2. And I can't do anything with the square root of 2. The next thing I'm going to do is simplify. I'm going to simplify each of those radicals that can be simplified, and then I'm going to multiply. Okay, so as I look at that, 3 times the square root of 16 is 4, times the square root of 2. Square root of 25 is 5, times the square root of 2. And then bring down plus the square root of 2. 12 times the square root of 2 minus 20 times the square root of 2 plus the square root of 2. Okay, now all of those are like terms. Okay, so 12 square roots of 2 minus 20 square roots of 2 is negative 8 square roots of 2 plus the square root of 2. Okay, so then negative 8 square root of 2 plus the square root of 2 is negative 7 square root of 2. That's the answer. Now, for the next one, look at all the perfect squares that I have, all the numbers that I have here. Do I have perfect squares? Yes, I do. I have a perfect square of 4 that will go into this one. I have a perfect square of 100 that will go into this one. And then right off the top of my head, I don't remember what will divide evenly into 245. But what I would do, and I'm going to do with the calculator, is I would divide 245 by 5 and see, it's 49. So 49 is the perfect square that divides into that. Now, why did I choose 5? Because 5, this is divisible by 5. So I can rewrite these as 9 times the square root of 4 times the square root of 5 plus 12 times the square root of 100 times the square root of 5 plus 2 times the square root of 49 times the square root of 5. Okay, now I'm going to simplify those radicals. 9 times 2 times the square root of 5 plus 12 times 10 times the square root of 5 plus 2 times 7 times the square root of 5. So multiply the ones that don't have a radical. That'd be 18 square root of 5 plus 120 times the square root of 5 plus 14 times the square root of 5. All of these are like terms. That doesn't always happen. This could have been the square root of 3, and that's okay. You just wouldn't combine them. So I can combine them all since they all are like terms. So I would have 18 square root of 5 plus 120 square root of 5 is 138 square root of 5 plus 14 square root of 5. Those are still like terms. 138 plus 14 is 152 square root of 5. Okay, so there is the answer to number 3. And again, I want to tell you that if you had this problem, so this is definitely not that problem. If you had 18 square root of 5 plus 120 square root of 5 plus 14 square root of 3, then these two you would combine to get 138 square root of 5. And then you would just leave this with 14 square root of 3. You cannot add those together. They do have the same root, but they also have to have the same number under the radical. So that's the answer to that problem. Okay, now, number 4, when multiplying, you can just multiply. The only rule that you have is that you can multiply a square root with a square root, no matter what the number is under here. You can multiply a cube root with a cube root, so on and so forth. But you can't multiply a square root with a cube root until you turn them into rational expressions, rational exponents, I should say. And then you can work with those exponents, but you can't just with the radicals. Okay, so now as I look at number 4, I have all square roots, so I'm okay. And I'm going to go the long way when using the distributive property just to show you. You've got 3 square root of 2 times the square root of 3. And you've got plus 3 square root of 2 times 4. Okay, now, 3 doesn't have anything to multiply with, so I'll keep the 3. Square root of 2 times the square root of 3 is the square root of 6. Multiply what's under the radical. Plus, there's no other radical, so the square root of 2 is going to be in my answer. 3 times 4 is 12. And these are not like radicals, so this is my answer. to number 4. With number 6, we're going to distribute. I'm going to distribute the square root of 6 to these two. And then I'm going to distribute this negative square root of 5 to these two. Okay, so the square root of 6 times the square root of 6, I think I'll write this out just the first time. If I were you, I'd just multiply them, but I just want you to see. Square root of 6 times positive square root of 5, so it's going to be a plus sign. And then negative square root of 5 times square root of 6, so minus square root of 5 times the square root of 6. And then negative square root of 5 times square root of 5, so minus square root of 5 times the square root of 5. And then just multiply. These are the same radical, so I'd have the square root of 36, same root I should say, 6 times 6 is 36, plus same root, so I can multiply, 5 times 6 is 30, minus 5 times 6 is 30, and then minus 5 times 5 is 25. Now simplify. The square root of 36 is 6. Positive square root of 30 and negative square root of 30 makes 0. And then I have minus. The square root of 25 is 5. 6 minus 5 is 1. So 1 is my answer there. And then my last one, I have all cube roots, so I can just distribute. I've got the cube root of 2 times the cube root of 4 minus the cube root of 2 times the cube root of 320. Then I would have the cube root of 8. 2 times 4 is 8. Minus the cube root of 640. Now I know the cube root of 8 is 2. And I know 64 is a perfect cube, so I can rewrite that as minus the cube root of 64 times the cube root of 10. 64 times 10 is 640. And then I can keep this 2 here. The cube root of 64, so minus 4 times the cube root of 10. That would be my answer to number 6.